A warm welcome to video number 5 for chapter 1 of Maths 2 Standard 9. We are discussing practice set 1.2, question 6, sub-question 3. The number line is given for reference over here. We have to find distance UV, distance PC, distance VB and distance UL. Now the coordinates of U and V are minus 5 and 5 respectively. We know that minus 5 is greater than, we know that 5 is greater than minus 5. Therefore, distance UV is equal to 5 minus minus 5, which is equal to 5 plus 5. The answer is 10. Next is distance PC. The coordinates are minus 2 and 4. 4 is greater than minus 2. Therefore, distance PC is equal to 4 minus of minus 2 is equal to 4 plus 2. The answer is 6. Third is distance VB. The coordinates are 5 and 2. 5 is greater than 2. Therefore, we have distance VB is 5 minus 2, which is 3. And the last one, distance UL. The coordinates are minus 5 and minus 3. Minus 3 is greater than minus 5. So we have distance UL is equal to minus 3 minus of minus 5, which is equal to minus 3 plus 5. The answer is 2. With this, we end practice set 1.2. We move to the next concept, which is something called as conditional statements and converse. Let us see what this is. The statements which can be written in the if-then form are called conditional statements. The part of the statement following if is called antecedent, and the part following then is called consequent. For example, consider the statement, the diagonals of a rhombus are perpendicular bisectors of each other. The statement can be written in the conditional form. This statement can be written in the conditional form as, if the given quadrilateral is a rhombus, then its diagonals are perpendicular bisectors of each other. Now here the antecedent and consequent in a given conditional statement are interchanged. If we interchange it, then we get something called as a converse of the given statement. If a conditional statement is true, its converse it is not necessarily true. We'll see this part a little later. Let us see what is a conditional statement and what is a converse. A conditional statement, if a quadrilateral is a rhombus, then its diagonals are perpendicular bisectors of each other. If we interchange this, we get something called as, or something as, if diagonals of a rhombus are perpendicular bisectors of each other, then it is a rhombus. This is converse. Another example, conditional statement, if a number is a prime number, then it is even or odd. Its converse would be, if a number is even or odd, then it is prime. Now, my dear students, a conditional statement is true, but its converse it not always true. Now, in this case, if a quadrilateral is a rhombus, then its diagonals are perpendicular bisectors of each other. We know that this is true. Let's see the converse. If diagonals of a quadrilateral are perpendicular bisectors of each other, then it is a rhombus. The converse is also true in this case. But let's see another case. If a number is a prime number, then it is even or odd. And the converse is, if a number is even or odd, then it is a prime number. Now we know that this is false. So sometimes the statement is true, but its converse is false. Let us move to next. Now next we are going to see what are proofs. But before we go to see what is proof and the various terms involved, a little bit of history. Now, the in this particular standard, we are going to look at the subject geometry with a different point of view. This was originated by Greek mathematician Euclid. You have his picture over here for reference. He lived in the 3rd century before Christian era. He gathered the knowledge of geometry prevailing at his time and streamlined it. He took for granted some self-evident geometrical statements which were accepted by all and called them postulates. He showed that on the basis of postulates, some more properties can be proved logically. And these properties proved logically are called theorems. So here we have some very famous postulates given by Euclid. You can read them a little later. Now, a property is supposed to be true if it can be proved logically. It is called a theorem. Now, the logical argument made to prove a theorem is called its proof. Now, when we are going to prove that a conditional statement is true, its antecedent is called given part and the consequent is called the part to be proved. There are two types of proofs, direct proof and indirect proof. Let us see what is a direct proof first. Now over here, my dear students, the statement is called as theorem. On the basis of theorem, we have certain given information that is called as antecedent, and what we are going to prove is the consequent, and that is to prove. And this is the proof where we are going to make the argument. So let us begin. This is, my dear students, this is just for reference as we are starting with proofs. This particular direct proof is, I'm going to explain how to write a direct proof. So theorem, the opposite angles formed by two intersecting lines are of equal measures. So given information is two intersecting lines, line AB and line CD, which intersect at O. We have to prove that angle AOC is equal to angle BOD and angle BOC is equal to angle AOD. So let us begin. Angle AOC plus angle BOC is equal to 180 degree because these are angles in linear pair. So that is what we write. We name it as statement 1, and besides statement 1 we have to write the reason. Why are we saying that it is equal to 180 degree? Because they are angles in linear pair. Similarly, angle BOC plus angle BOD, this angle and this angle is 180. Again angles in linear pair. This we name as statement 2 and write the reason as angles in linear pair. Now compare both. Both are 180, 180. So I can say that statement 1 is equal to statement 2. And how and on what basis am I saying that as? From 1 and 2. Now if you see, here also there is BOC and here also there is BOC. So from left hand side and right hand side, whatever is common, I can just eliminate that. And I'm left with angle AOC equal to angle BOD. The reason? Eliminating angle BOC. Now this is my first set proved. Similarly, I can prove the second set. So I write, similarly, it can be proved that angle BOC is equal to angle AOD. This is an example of direct proof. Now let us see an example of indirect proof. Now this type of proof starts with an assumption that the consequence is false. Using it, the properties accepted earlier, we start arguing step by step and reach a conclusion. The conclusion is contradictory and the antecedent or a property which is already accepted. Hence, the assumption that the consequent is false goes wrong. So it is accepted that the consequent is true. Now let us see what all this is. With an example, statement a prime number greater than 2 is odd. Conditional statement for this, if P, we are assuming that P is a prime number greater than 2, then it is odd. Given information on the basis of the conditional statement, P is a prime number greater than 2. Okay. That is, 1 and P are the only divisors of P. Why do we write this? Because we know that prime number means its divisor is 1 and the number itself. And what do we have to prove? We have to prove the next part, that P is an odd number. So let us start with the proof. We have to assume this particular statement is false. That is how indirect proofs are. We start. So let us suppose that P is not an odd number. If P is not an odd number, that means it is an even number. Therefore, a divisor of P is 2. If it is an even number, it is divisible by 2. So I am naming this as statement 1. But then I write, but it is given that P is a prime number which is greater than 2. See, here it is, we have the given information. And the reason for why I am saying this is because it is given. Now, therefore, 1 and P are only divisors of P. Now, from where have I written this? Again, part of given information, 1 and P are only divisors of P. This is my statement 2. If I look at statement 1, a divisor of P is 2 and 1 and P are the only divisors of P. This both, they don't match. They contradict each other. So I'm writing statements 1 and 2 are contradictory. Therefore, the assumption P is not odd is false. So on the basis of this, now I'm saying that means what I assumed is false. So if my assumption is false, that means what was told to me, that has to be correct. So this proves that a prime number greater than 2 is odd. This is how indirect proofs are written. This is all for now. We will meet in the next video. Thank you for watching.